Swayam Prabha. Digital India. Educated India.
Here is one more example. So we looked at loop unrolling. Maybe it's a good time to take to understand how loop unrolling can be done. After you have seen the benefits, wait, let's see. Let me see if I can share a blank slide. Okay, all of you can see the blank slide, right?
Yeah.
Good. See how. See, if I have a for loop, okay, where I have some initialization, some condition, and some other increment statement. I'm not even showing what the code is, okay? And the body yes. And I have been told unroll it so many times. I'll show it for doing it twice, okay? So what should be the code for the same initialization that shouldn't change? Condition can remain the same. Increment can remain the same. S, increment S. Do you see that this particular code is equivalent to this code? So this is the original. This is the optimized. Do you see that the particular code is equivalent?
You will have to check the condition after the increment.
Very good. That's one more thing that's pending. If I know, see, if I am adding this condition, if condition, rather, if not condition break, then I haven't gotten all the benefits of unrolling that I talked about. Let us say I know this condition. Let us say I know this condition. Can I do anything better? Let us say my code is like this. It's a for loop. I less than 2n. Or rather I less than n, I plus plus. I want to, like before, unroll this loop body loop by one so that I'll have two bodies of S. So what I will do is the following. See, there are two possibilities, right? N is a multiple of 2, n is not a multiple of 2. So what will I do is the following. I can write m equal to n integer division 2 multiplied by 2. Okay, I equal to 0, I less than m, I plus plus. Okay. And what will I do? So I know now that so if I write S and S, if I write this is great. So instead of writing I plus plus, I'll make it as I equal to I plus 2. And in this is S, and here I will write it as every occurrence of I, replace it with I plus 1. Do you see here I do not need if condition break? Can you see why?
You can use it outside the.
Sorry?
I think you can use it outside the loop.
No, I couldn't hear you, sorry. I couldn't hear you, I'm sorry. Can you be slightly louder?
So, I think we can use the condition
You're saying we still need the condition check here?
It's a
Yeah, so this is the equivalent code. So what did I do? I took the, if let's say n is 11, m becomes 10. So I will execute the loop from 0 to 10. And the last iteration, I'm doing it separately. Actually, don't need a for here, but fine. So instead of 2, if I'm unrolling it with k, then I will replace this with k. Replace this with k. And I will have so many copies of s here. And here I equal to I plus k. K minus 1. So what did I do? I just unrolled the loop so many times. Is this fine? Do you see that this loop can always be transformed to this loop and this is correct? I have reduced the number of condition checks and number of jumps. Guys, Siddharth Jain, Meenakshi, any questions?
No, thanks, I'm good.
Okay. Sneha Sopori.
no questions.
Okay. Thank you, Aditi. Shambho, any questions? Okay. Okay. So this is the idea of loop unrolling. Right? So loop unrolling, what did we do? We took the loop, we modified it. We modified the loop slightly so that if I'm unrolling it, if I'm repeating the body k times, this m is a multiple of that k. Okay? Fine. If you are fine with the idea of loop unrolling, we will go to another cool example called loop invariant code motion. One more optimization. Okay, let me start sharing my slides.
Sir, I have a question.
Sure.
In the first slide about loop unrolling, you mentioned like subtle secondary effects. Those.
Yes. And the question is?
Like what are those?
Very good. See, what happened is I have increased the size of the loop body. Correct?
Yeah.
As a result, it can impact few other things, namely instruction scheduling, register allocation,
Okay.
and so on. Okay, and these things are not very easy to reason about. So I just put it as there are effects. Let's be aware of them.
Right.
Good question. Good question. Vikram, you had a question? Your hand is raised. Go ahead, Vikram.
No.
Okay. Okay. Rupanshu, very good question. Rupanshu, where are you from?
Bits Pilani, sir.
Bits Pilani. Which campus?
Hyderabad.
Anyway, all right. All right. Cool. Let's go with one more optimization called as loop invariant factoring or loop invariant code motion. What is a loop invariant? Loop invariant is an expression which remains constant throughout the loop and it is computed within the loop. Okay, let us say I have a loop. In this, I am computing some expression. If the value of this expression does not change, then it's a loop invariant. I can actually compute this expression outside, something like I'll write T1 equal to EXPR, and wherever this EXPR is there, I'll just replace it with T1. Do you see that this is efficient? Anupam, Geneva?
Not sure.
Here inside the, let's say the loop goes over 100 times. How many times am I evaluating this expression?
100 times.
Very good. Once I do this transformation where this expression is moved out, how many times am I evaluating this expression?
Once.
So which is more efficient?
When we are moving out the expression.
Correct. So the loop independent code here executes only once. Right?
Yes.
All right. So let's look at a small piece of code. Okay. You may wonder, why should anyone write code which is loop invariant? Not always people write it explicitly, but let's look at the simple code. I have a for loop that for loop nest 100, 100, 100 cross 100 cross 100, and I'm initializing the values of this three-dimensional matrix A. Do you see that I have total 100 cross 100 cross 100 iterations, and here I have 3 million index operations, correct? Yes or no? Because A sub ijk is same as A sub, you do A sub I, then do sub j, then do sub k, correct? So this is 3 million index operations, 2 million multiplications. Are we fine so far?
Yes.
Vishnu, Ajit,
Yes, sir.
any questions so far?
No.
Okay, good. What about you, Yashas? Any questions, Yashas? Or you are okay with this example and what it does so far? Yashas Andaluri. Rajat BLR. Or Beer, is it? My eyes are not very clear.
Yes, sir, it is me. Rajat Beer.
Okay, Rajat Beer. Okay. My eyesight is good. Okay. Fine. Be ready for a shock now, okay? Within 10 minutes, if you're not shocked, let me know. Are there any loop invariant codes here? Or rather loop invariant expressions here?
I and J are invariant for the K loop.
Just the variable I is not interesting. However, I and J are invariant, yes. But we are looking for an expression, not just a variable. I and J do not change within the K loop. That's a very good observation. What does it mean? What's the consequence, I mean?
I can just multiply k to the next value in the array and then add the one below that and the one below that.
Very good. So what I can do, this I times j, I can compute it once here. Correct? I can write T1 equal to I times j and replace this with T1. Correct? How many multiplications will it be then? Anupam, you are saying something?
Yeah, 1,010,000. 10,000.
1 million and 10,000. So by this, the number of multiplications from 2 million, it has come down to 1 million 10,000. Is there any other loop invariant expression here?
I is invariant in the J loop.
But I mean, I is just a single variable. I'm not doing any computation, right?
I guess accessing AIJ.
Absolutely. So look at this way. This Aij is invariant for the K loop. So I could do T2 equal to A sub Ij and then do T2 sub K equal to blah, T1 times K. But here again, there is one more invariant. Do you see this? A sub I is an invariant for the J loop. So I could write T3 equal to A sub I here and write T2 equal to T3 sub J. How do you like that? In this case, how many index operations will I have? Let me show the code. Let me show. Yeah, how many index operations do I have? There is 1 million index operations here, 10,000 index operations here, and 100 index operations here. So compared to 3 million, it became 1 million plus 10K plus 100. And instead of 2 million, it became how much? 1 million plus 10K. Oh, sorry, 1 million. 1 million multiplications. No, why? 1 million plus 1 million plus the outside is 1 there. Then 10K. Do you guys see the impact of loop invariant code motion so far? Any questions? We will now see how to do loop invariant code motion.
I had a question. Like, we did like T3 equals to A of I. So won't that increase the space, like, because we fetch the complete AI index?
No. Oh no, we don't get the full array, right? I mean, when we do T3 equal to A sub I, it is just one load of that address, A sub I. Right?
Okay. Just the address. We're just getting the address. Okay.
Yes. There is no. See, when we write A, what is A? A is an array. That means it's just an array. I mean, it's the beginning of the memory which holds this whole array elements. In C, Java, we don't pass the full array, right? We just pass the address.
Yes, understood.
Okay. Any other question? No? Okay. See, the loop, when we did this loop transformation, right? We want to know whether it is, Yeah, we want to again see safety. Is it safe to do? Where is the opportunity? Where is the profitability? Okay. So we will, for loop invariant code motion, let us study the same things. How to find the opportunity? How to do? Is it safe to do? And is it profitable? Okay. What's the time now? 10:26. I think we can. Ramakrishna, is it okay if I take if I go till 11:35 and take the break there? Or other students, do you have any issues? Because this will take 5 to 10 minutes to close this loop invariant part. Yeah. Okay, I'll go ahead. Okay. See, loop invariant code motion, to do this, let's get some definitions. What is a loop invariant? It's an expression which remains constant within the loop body. Okay? Which remains constant within the loop body. We'll define something called a relevant variable. What is a relevant variable for an expression? Relevant variables for an expression are those variables that are used to compute that expression. Okay? So first to do loop invariant code motion, what will I do? I'll first identify the variables which are defined in the loop. Defined as in return to. Defined as in return to. I will call that set as loop def. Now I will pick an expression and check if it is a loop invariant. How will I know it's a loop invariant? A loop invariant will have no relevant variables in loop def. Let us say my expression I have is p plus q minus r. This is the expression I'm talking about. So if for me to declare this expression as loop invariant, p, q, and r should not be in loop def. Okay? Then what will I do? I will assign this whole loop invariant and every other loop invariant I find to a different temporary in the loop header. So if the loop starts here, before this I will write t equal to p plus q minus r. And in this, wherever there was p plus q minus r, I'll replace it with t. Okay? So in the loop body, I will use this newly created temporary instead of this loop invariant expression. Is this idea clear? I find out what are the variables defined in the loop, defined as in return to, that I call as loop def. Then find out loop invariants. Okay? Let us say I have done the following, okay? But any questions on the opportunity part on how to identify loop invariants? Mayur?
Yes, sir.
Any questions?
No, sir.
Okay. Gagandeep, any doubts?
Sir, why it is written loop invariant expression may throw exception?
I'm coming to the safety part. Let's understand.
Okay.
Ayushi?
No questions so far, sir.
Thank you. What about Atharv?
No questions.
Very good. Okay. Let us say I have the following code. Loop. Then I'm writing if condition, throw some exception, okay? Throw some exception, details I'm skipping. And here I have the same loop invariant that I was talking about. P plus Q minus R. Okay? If I move this code here, and I write T equal to P plus Q minus R. In the actual loop, this should have executed only if the exception is not thrown. Correct? Yes or no?
Yes, sir. Yes, sir.
But now I'm executing this code first and then later I may throw an exception. You may say, what's the big deal? Right? You may say, what's the big deal? I'll show you what's the big deal. Let us say the code is like this. If P equal to null, throw exception. Okay. This is capital null. Don't take it as thing. C++ capital null. And otherwise, I'm accessing P arrow field. X equal to P arrow field. Okay. Now, this part is loop invariant, isn't it? P is not changing anywhere. P arrow F is loop invariant. If I move this thing outside the loop, what will happen? The code will be, I'm writing in the middle all around. The code will be T equal to P arrow F, then loop. Somewhere here I have a throw followed by X equal to T. If P is null, what will happen? This will be a seg fault. Isn't it? Here I should have thrown this a different exception. So do you see that loop invariant code motion? When I'm moving the expression, I have to be careful that if there are exceptions that are thrown, I shouldn't move the code above. Naively like this. Does it make sense? Why these exceptions can change the semantics? Do you see that if I have code like this loop here, this is not equivalent to this loop? Kuldeep, Gautam?
Yes, sir.
Do you see that the loop here, I marked this with A, is not same as the loop marked with B? It's not equivalent.
Sir, it's not properly visible to me actually.
It's not clearly visible, right? Let me write it again. Let me start sharing the... Okay. See, the code was like this. You can see what I'm writing, right? See, this was my loop. I replaced it with I found that P is not changing in the loop. Now I'm saying, do you see that this loop is not equivalent to this, the first loop? Kuldeep? Is the code
Yes, sir.
equivalent?
Yes, sir. Yes, sir.
Why is it not equivalent?
Sir, basically, this is,
Anyone else wants to answer?
Because we are not checking like the if P is null in the second case. We
Correct.
just quickly assign.
This may throw a segmentation fault here. Correct? If P is null.
Yes, sir.
Okay, so that's what I was saying by the loop invariant expression may throw exceptions early, which we want to avoid. Okay? Can someone tell when is loop invariant code motion profitable? If the loop executes, loop should execute at least once. If loop executes 0 times, then we have done the computation unnecessarily. Okay? Similarly, if the expression is this loop invariant code is inside a if branch and that branch is taken rarely, then moving it or that branch is never taken, then loop invariant, moving it out is not profitable. But more or less, loop invariant code motion, assuming that the loop is executed more than once, it's a good image. So as we saw, this particular code, we can replace it with this way, where I move the a sub I, a sub ij and this multiplication. As a result, I get much fewer number of array indices, array index operations and multiplications. Okay,